According to the Bureau of Labor Statistics, the average weekly pay for a U.S. production worker was $441.84 in 1998. Assume that the available data indicate that the wages are normally distributed with a standard deviation of $90. Well, here again, we know that we're working with a normal distribution, and we have the mean 441.84, and we have the standard deviation. These are the three things that we need to work probability problems for a continuous random variable. So let me draw a little picture of this distribution just to kind of help organize some of the numbers here. We have a mean centered 441.84, a standard deviation of 90, and a question, probability question. What is the probability that a worker earns between $400 and $500? Okay, 400, so maybe about right there, there would be 400. And then the 500 would be a little closer to one standard deviation, but my interval there is between 400 and 500, and I'm looking for the probability that X is between 400 and 500. Okay, so it's the area under the density function above the interval. It's what we want. And we'll need the standard normal table to do that. But to communicate to the standard normal table, we'll have to find the z-scores, because the standard normal table works with the z-value. So let me find the z-value for 400. So it'd be 400 subtract 441.84 divided by 90. And I get negative 0.46, and then the z-score of the 500, the other side of the interval, subtract the mean again and divide it by the standard deviation, I get 0.65. Alrighty, now let's go to the table, and for this negative 4.6 and a positive 0.65. Let's look up the 0.65. So 0.65 is 0.6 plus 0.05. So it's 0.2422. So this is 0.2422. And to get the other side of this, again, the standard normal table reads from the center. If I look up negative 0.46, well, the table doesn't have negatives, so I have to look up a 0.46. But because of symmetry, looking up the 0.46, the positive 0.46, I'll get the area I need. So 0.46, there's 0.4, and so 0.1772. So this part of the table, or the graph, is 0.1772. Now to get the total area, probability that X is between 400 and 500 is the same as the probability that Z is between negative 0.46 and 0.65. And to get that, then we just add the 0.1772 and the 0.2422, and we get 0.4194. Between $400 and $500, there is a 41.9% probability of that. Part B says, for a randomly selected production worker, what is the probability the worker earns less than $250 a week. Earns less than $250 a week. Now let's see, 250 is way out there to the left, the standard deviation being 90. I'm going to put the 250 way down here on the end. And it says the probability the worker earns less than, so we're talking about the area under the curve. So the probability that X is less than 250, and that's basically from the 250 down to negative infinity. Okay, so find that area. I've got to find the z-score of the 250. So z is equal to 250, subtract 441.84 divided by 90, and I get a negative 2.13. And so the 250 has a z value of negative 2.13. But I have to look up a positive 2.13, and the table will give me the area out to that value. So 2.13, let's go to the table. 2.1, scroll down there a little bit, 2.1 and 0.03. Looks like 0.4834, 0.4834. So 0.4834. Of course, by symmetry, this is the same as this area here. So to get the area that I want, remember again that right down the center I got 50% probability on each side. So this piece that I want would be 0.5 subtract 0.4834. So I've got the probability that X is less than 250 is the probability that Z is less than a negative 2.13, which is 0.5 subtract 0.4834, 0.0166. For a randomly selected production worker, what is the probability the worker earns less than $250 a week? There's a 1.7% chance of that happening, or 1.7% of the production workers earn less than $250 a week. So if I selected one at random, there's a 1.7% chance I will get a production worker in that range, that pay range. Okay, part C, 20% of wage earners make less than what weekly amount? 20% of wage earners make less than what weekly amount? So we're talking about the lower 20% of the workers, and we want to know what amount they make less than. So I need to find the X there. So with 20%. Well, to find the X, as you've seen in other examples, we have a z-score formula that relates everything here. The mean, the standard deviation, the z-score, and a particular value of the random variable. And we're looking for this X. If we can find its z-score, then we'll be able to solve the problem. Now, X is going to be to the left because they're talking about the lower 20%. So that would be a negative Z. And I know that the table always reads from the center out. So just by symmetry, what I need to look up to find that Z is the area 0.30. Again, because 50% of the data is to the right and 50% of the data is to the left of the mean. The probability 50% on the right, 50% on the left. And by all this symmetry and trying to get value from the table that will help, I've got to get the positive value, the absolute value of this negative z that I want. And I'm going to have to look up the 0.3 to do it. So I need to get as close to 0.3 as I can get. That looks like it's going to be a 0.2995. So it looks like that is in row 0.8 and in column 0.04. For my area of 0.2995, I'm going to get z as 0.84. And so let's take that back, the 0.84. Of course, the z I want is a negative 0.84 because, again, my x is going to be on the left. Now let's look at the z-score formula. So negative 0.84 z, that's the z, x minus 441.84, and then divided by 90, and solve for x. See how we needed the z-score there to plug it into the formula so that I could solve one equation with that one unknown x. And again, multiply both sides by 90. And then add, and I get x equal to 366.24 dollars. So 20% of wage earners make less than what weekly amount? $366.24. 20% of wage earners make $366.24 or less.